Welcome. Year 9 mathematics test practice. This is Pythagoras and trigonometry. So number 1, label the sides of the triangle below, opposite, adjacent, or hypotenuse. The reference angle has been labelled for you. So here's our reference angle X. And we need to label this triangle opposite, adjacent, or hypotenuse. Okay, so the hypotenuse is always the longest side. The longest side of a triangle, the hypotenuse. The adjacent is next to the angle. So there's our adjacent. It's right next door to this angle X. And opposite is the one away from the angle. Okay. Question 2. Consider the triangle ABC below. Here we've got the triangle A, B, and C. Which of the following represents the ratio opposite over adjacent for angle B? Circle the correct answer. So the angle B is here. So this is B, and this is angle B in there. Okay, so what's opposite over adjacent? So this is the opposite side here. That's the opposite. And this is the adjacent. So what's the ratio of opposite over adjacent? That's going to be 3/4. So let's have a look. And it's this first one. Okay, so that's the answer there. Which of the following represent the cosine ratio of angle C? Cosine ratio of angle C. So let's have a look at that. So here's angle C. I'll do it in red. This is angle C here. Angle's in there. So the cosine ratio, you've got to remember, so, ka, toa. Okay. So cosine is adjacent over hypotenuse. All right, so here we've got the adjacent, and here's the hypotenuse. And my mistake, that's for angle B. This is the adjacent for angle B. So the adjacent for angle C is here. Adjacent's there, and the hypotenuse is here. So cosine, adjacent on hypotenuse, that's going to be 3/5. So the cosine of angle C is equal to 3/5. Let's have a look at that one. It's here. 3/5. Which of the following could be used to calculate the length of side Y? Do that in blue. The side Y. So here's where Y is, and we've got this angle here, 61. Okay, so Y is opposite 61. This side here is the adjacent, and this side here is the hypotenuse. Let's have a look. And sine of 61. So using so, ka, toa, sine is opposite on hypotenuse. So opposite on hypotenuse, that's going to be Y on 36. And there it is, sine 61, Y on 36. Okay, that's the one we would use. So let's have a look. What's the cos of 61? The cos of 61 is equal to the adjacent on hypotenuse. The adjacent is 18, yeah, over the hypotenuse, 36. So nope, that one's wrong. This one here is wrong. That one's wrong as well. The tan of 61, just for interest, the tan of 61 is equal to the opposite on adjacent. So that's going to be y on 18. Y on 18. Nope, that's wrong as well because it's 18 on y. So tan of 61, y on 18. So our first answer there is correct. Number 4. Which of the following would be used to work out angle C? So here we have angle C. And we need to figure out what it is. So I've got so, ka, toa. And let's do sine first. So sine of angle C is equal to opposite on hypotenuse. So this is the opposite. This is the hypotenuse. That's the adjacent. The opposite is 10 over 24. And C is going to equal sine to the -1, 10 over 24. And look, that's this answer here, the first one. So we look, and just for interest, let's do cos. Cos of C is going to be the adjacent on hypotenuse. So we don't know what the adjacent is. So whatever it is, it would be the adjacent on 24. So nope, that one's wrong. That's wrong. And this one's wrong. Okay. Number 5. Write the next line of working for each of the equations below. This is what you would put in the calculator. So tan of 23 equals 43 on B. So B is going to equal 43 divided by tan 23. So that's what you would type in. So these two would switch positions. Okay. Sine theta equals 5 on 46. So you would type in shift sine to the -1. So you get sine to the -1. 5 divided by 46. Number 6. Draw a diagram to represent the following situations. You do not need to solve the problem, and the diagram does not need to be to scale. The triangle ABC is a right-angled triangle where A is 40 degrees, AC is the hypotenuse, and AB is 10 meters. How long is side BC? You just have to simply draw the diagram. You don't need to solve the problem. So here we've got our triangle. Okay. AC is the hypotenuse. A to C is the hypotenuse, the long side. Angle A is 40 degrees. There's angle A in there. And AB is 10 meters. So A to B, so there's our right angle. A to B is 10 meters. And that's it. Okay. So all you need to do is just draw the situation. You don't need to solve it. Angela sees a rocket at an angle of elevation of 13 degrees. The rocket launch pad is 7 kilometers away from Angela. So here's where Angela is. And a rocket, so here's the rocket R. Angle of elevation, 13 degrees in there. And the launch pad, here's the launch pad, 7 kilometers away. So here's our angle of elevation. It goes up 13 degrees. There's our launch pad. There's our rocket up in the sky. And there's 7 kilometers distance between Angela and the launch pad. Okay. Now for this section, you're allowed to use a calculator. All right. So number 7, find the value of x in each of the following diagrams. So for this first step, we're going to use Pythagoras. And what you need to do is realize that this side here is the hypotenuse. And these two are the short sides. So we've got side A, B, and we're going to call this one C. So C squared equals A squared plus B squared. All right. Then, putting those numbers in, we've got 5.7 squared. So substituting in 5.7, my mistake. C is x. So it's going to be x squared equals 5.7 squared plus 6.3 squared. Then solving, (5.7) squared plus 6.3 squared is, so x squared is going to equal 72.18. X equals the square root of 72.18. X equals, let's find square root of 72.18, which gives 8.4, closer to 8.5, 8.50. That's our answer. And this one, x is there. So here we've got our angle 43. We need to use SOHCAHTOA. SOHCAHTOA. So we look, we've got opposite here. We've got adjacent there. So it's going to be, opposite and adjacent is tan. This side here is the hypotenuse. There we've got opposite and adjacent, we're going to use tan. So tan of 43 equals x over 15. X equals 15 times by the tan of 43. X equals 13.99. 13.99 there. Okay, number 8. Find the missing side lengths and angles for the following triangles. Okay. Now, first step, we've got this angle here, alpha. Okay, so we need to use SOHCAHTOA again. SOHCAHTOA. And we look, this side's the opposite. This side's the adjacent. This side's here the hypotenuse. So we can use tan. Tan of alpha is equal to 54. It's equal to the opposite over the adjacent. So that's 54 over 37. 54 over 37. Alpha equals tan to the negative 1. 54 divided by 37. Alpha equals 55 degrees. Okay. Next one. We'll do beta. Okay. We've got here adjacent and opposite. Okay, so again, we can use tan. So the tan, for this case, beta is this side's the adjacent for beta, and this side's the opposite. This side remains the hypotenuse. Longer side, always the hypotenuse. Here we've got adjacent. This side's adjacent, that side's opposite. So tan of beta is equal to the opposite over adjacent, which is 37 over 54. Beta equals tan to the -1, 37 divided by 54. Beta equals 34.42 degrees. Okay. Now, this unknown side C. So that side length, we can use Pythagoras. So C squared is going to equal 37 squared plus 54 squared. C squared equals 37 squared plus 54 squared gives 4,285. So C equals the square root of 4,285. C equals the square root of 4,285, which is 65.46. 65.46. All right. B. Now, inside a triangle, there's 180 degrees. So straight away we can figure out this unknown angle there. So 180, take 90, take 32, gives 180, take 90, take 32 is 58. So alpha in there is 58. Alpha equals 58 degrees. Okay. And this unknown side C. So here's our hypotenuse, 580. We can use Pythagoras. So it's going to be 580 squared is equal to C squared plus 490 squared. So C squared is going to equal 580 squared, take 490 squared. C squared equals 80 squared, take 490 squared, which leaves 96,300. C equals the square root of 96,300. C equals 96,300, which is 310.32. Find the missing angles for the following triangles. Okay, so this question just asks just for the missing angles. So let's figure it out. Here, we've got angle alpha. So this side is the adjacent. With the 67, it's adjacent, it's next door. This side, the hypotenuse, the longer side. And this side here, the opposite, it's away from the angle, so it's the opposite. Okay, so we've got to use SOHCAHTOA again. SOHCAHTOA. And look, I've got a 76 and a 67, meaning I can solve it using tan, because tan is opposite and adjacent. So that's what I've got. So the tan of alpha equals 76, opposite over adjacent, over 67. So tan of alpha equals 76 divided by 67. So alpha equals tan to the negative 1, 76 divided by 67. Alpha equals 76 divided by 67, which is 48.6. 48.60 degrees. And now, inside a triangle, added up all these angles, they add to 180. So we know this one here is now 48.6 degrees. So we can now add them up. 180, take 48.6, take 90, because that angle in there is 90 degrees. That will give us beta. Beta equals 180, take 48.6, take 90, is 41.4. And it said find the missing angle, so we didn't need to find that unknown side C. This one's an easy one. It's just going to be 180, take 90, take 35 to figure out that alpha. That is 180, take 90, take 35 is 55. So alpha equals 55 degrees. And that's it. The diagram below, find the length of W. So here's where W is. And so here's our angle. So this side here is the hypotenuse, the longer side. This side's the adjacent. Here's the opposite. So we need to use SOHCAHTOA again. SOHCAHTOA. We've got a adjacent and we need to find the opposite. So where's adjacent and opposite? And it is tan. So tan of 39 equals W on 84. So W equals 84 times by the tan of 39. W equals times by the tan of 39, which is 68.02 meters. That's W. W equals 68.02 meters. So what was the next one? Find the value of X. So now we know that this is 68.02. We can figure out what X is. So let's do that. So here's our angle X. And this again is opposite. This is hypotenuse and this is adjacent. So we can solve again using SOHCAHTOA. So we've got we know opposite, we know adjacent. We can use tan again. Tan of X equals opposite over adjacent, which is 68.02 over 60. X is going to be tan to the negative 1, 68.02 divided by 60. X equals 48.5 48 degrees. So 48.58 degrees. Find the length of y. Now y is this part here. Okay, so we'll circle that again. Y is there. So here we can use Pythagoras. So we're going to say y squared is going to equal 68.02 squared plus 60 squared. Y squared equals 68.02 squared plus 60 squared, which is 8,226.72. Y equals the square root of 8,226.72. Y equals 8,226.72, which is 90.70 meters. So 90.70 meters. All right, number 11. Bert is playing golf, and for his second shot, he can choose to hit the golf ball across the lake or follow a dog leg as shown. Okay, so he can go straight over the lake like that, or go with the dog leg, which runs like this. Goes that way, then that way. Okay. Calculate how far it is across the lake to the flag. So across the lake. So we need to figure out so this is the hypotenuse. This orange bit here, it's the longest side, it's the hypotenuse. And here's our angle 70. So over here we've got the adjacent. So here's our angle 70 there. That's the adjacent. This is going to be opposite. So we've got the adjacent, and the adjacent's 30. We need to figure out the hypotenuse. So let's use SOHCAHTOA, and we're told the adjacent is 30. The hypotenuse is what we need to figure out, so we're going to use cos. So cos of 70 equals the adjacent and hypotenuse. So that's going to be 30 over, I'm going to call the hypotenuse just h, just to make it easy, over h. Then these two switch positions. So h equals 30 over cos 70. H equals 30 divided by the cos of 70, which is 87.71 meters. Okay, so how long is the hypotenuse? How far it is across the lake? 87.71. If Bert had followed the dog leg, how much further did he have to hit the ball? So let's look at that. So first off, we need to find the length of this opposite side here. Okay, so we can use Pythagoras for that. So it's going to be the opposite side O, I'm going to call it O. So O squared plus, maybe I shouldn't use O. I think O looks too much like a 0, so I won't do that. So let's choose a different color, go black, and I'll call it A. No, I won't use A. Oh, the A is not too good. Let's call it K, so people understand. That's K, side length K. So K squared plus 30 squared is going to equal the hypotenuse squared. So it's 87.71 squared. And then solving for k squared. K squared is going to be 87.71 squared take 30 squared. K squared equals 87.71 squared take 30 squared is 6,793.04. So K equals the square root of 6,793.04. K equals 82.42 meters. Okay, so now we need to add up how much longer the two hits are going to be. So put it in the red. So this is the two hits. That first hit there, then there. Oops, undo that. The red. This bit there, and there. So the first hit is 30. The next hit is 82.42, which gives 30 plus 82.42, which is 112.42. And let's look, how much longer is that than just hitting across the lake? So it's going to be 112.42 take 87.71. 112.42 take 87.71, which leaves us with 24.71 meters. So if Bert followed the dogleg, how much further did he have to hit the ball? 24.71 meters. Okay. Number 12. Ernie is flying a kite. He has 100 meters of string to let out and ties the string to the ground. The kite's vertical distance from the ground is 60 meters. So here's where Ernie is. And he's flying a kite. That's 100 meters. There's 100 meters of string. And so there's the kite. And the ground is vertical distance, 60 meters. So here's the ground. What angle does the string make with the ground? So we're looking for this angle. What angle does the string make with the ground? This angle in there. Okay, so let's look at that. I'm going to call it angle E. So we've got to use SOHCAHTOA, angle E, so it's going to be opposite on hypotenuse, which is sine. Okay, so sine of E is equal to 60 over 100. E equals the sine to the -1, 60 divided by 100. E equals 36.87 degrees. Number 13, a flagpole stands on level ground. From a point 50 meters from its base, the angle of elevation to the top of the pole is 40 degrees. Draw a diagram of the situation. So here's a flagpole. So here's our flagpole. And from a point 50 meters from its base, so there's the flag. 50 meters from its base, here's the base. The angle of elevation to the top of the pole is 40 degrees. So there's angle of elevation up 40 degrees from this point 50 meters away. Draw a diagram. How high is the flagpole? So we've got this side's the adjacent. This side's going to be opposite. Here's the hypotenuse. So we've got opposite, we've got adjacent, and we need to figure out the opposite. So using SOHCAHTOA, that's going to be tan. So tan of 40 is equal to opposite over adjacent. So I'm going to call this, again, I'm going to call it side K, just to make things easy. K over opposite over 50. So K equals 50 times tan 40. K equals 50 times by the tan of 40, which is 41.95 meters. The part of a plane flying at an altitude of 1,500 meters sees an airport on an angle of depression of 30 degrees. So complete the diagram. So here's our angle of depression. It comes from the horizontal. So 30 degrees going down there. So if that's 30, then in here, take 30, which leaves us with 60 degrees. Okay, and there is 60. And determine the horizontal distance to the plane. The plane is, that should be is, from the airport. Okay, so we're looking for this distance in here. Horizontal distance. Distance there. Okay, so our plane's up here, and there it is. Okay, an angle of depression, 30 degrees. So it's 60 in there, and we're looking for this distance across there. So this, from this angle, 60, and here we've got adjacent. So we're going to use tan. So tan of 60 equals the opposite over the adjacent. So I'm going to call, again, my unknown, I'm going to call it K to make it easy. K over 1,000. So K equals 1,500 times tan 60. K equals 1,500 times tan 60, which is 2,598.08 meters. My battery's running low now. Better plug in my computer. What would the angle of elevation of the plane, what would be the angle of elevation of the plane at that time from the airport? So the angle of elevation, they're looking for this angle in here. This angle in there. So that angle there. I'm going to call it angle theta. Okay, the way to figure that out, all angles in a triangle add to 180. So 180, take 60, take 90, gives 180, take 60, take 90, leaves us with 30 degrees. Okay, so what's the angle of elevation? 30 degrees. And that's the end of our test. Well done.